Saxon Algebra 1/2 students, we are going back to lesson 63, which is giving everyone conniptions and taking a fresh look at how to approach these problems. The topic is changing rates, and what it all comes back down to always is our basic rate formula. I usually write it like this. Distance equals rate times time. Okay, in the years to come, I'm going to refer to these problems as, or problems like them. We're going to morph them into something bigger. I'm going to call them dirt problems. Distance equals rate times time. It kind of looks like the word dirt, doesn't it? So that's my shorthand. Notice that we can also just flip it around and say rate times time equals distance. All I did was just change this guy, these two guys over to this side and this to there. So this is the very same thing. It's just written in the other order, okay? So nothing has changed. I just flipped it around. Okay, let's talk about each of these components. Rate is, the easiest way to think of it is miles per hour. Okay, we're going to come back to it because this is the one that we pay the most attention to. I'm just going in order here. Time, that's easy. That's usually written as hours or days maybe, or seconds, right? It's a unit of time. And you're quite familiar with those. All right? So you can look at information and easily figure out which one is the time, because it's going to be measured in hours, days, seconds, minutes, weeks, whatever. You know what units of time are, and so it's easy to identify the time. Distance is also usually easy to identify because it's miles or it's kilometers, which is how everyone else in the world measures miles. Or sometimes it's something obscure, like John uses this, leagues, right? Which is not a unit of measure that we usually mess with. It could be feet. It could be inches, right? It can be any unit of length. And thus, distance is quite easy to identify as well because it's a unit of length, right? The rate is the one that we're usually paying attention to the most because it combines the two, right? It's a distance over a time. This is the most common one because everybody knows miles per hour because that's how our cars measure their rate of speed. But it can be any length, a unit of length divided by time. Okay? So that's a definition of each of these three components, and this is giving you really good clues as to how you can figure out when John gives you information in a problem, okay, which one's the time, which one's the distance, and which one's the rate. This will help you know that. Now, I'm going to do something. I'm going to take this basic equation again. Rate times time equals distance. I want it in this shape, and I want to show you something. We don't do a lot of this yet, but we're going to do more. This is called an abstract equation because it doesn't have numbers. It just has letters. But we can treat it just like a numeric equation in terms of solving it. So I want to solve this equation for r, and so I have to get rid of this t. T is being multiplied by r, so I'm going to divide both sides by t. Right? Now, these cancel, and I get rate equals distance over time. Okay, and we say that distance is always a unit of length, And time is a unit of time. Okay, that's really easy. So look, by rearranging the formula, we can create a rate. This is important because it means that even if John doesn't tell us the rate, but he gives us the distance and the time, we can find the rate. Okay? Because we can find the rate by putting the distance over the time. And you don't really have to memorize that. If you just memorize this form, which is what we started with here, and just mentally remember that process of dividing the t, you can recreate this anytime that you want. That means that if John gives you information about the distance and the time, you can find the rate. And that is the trick to these problems, because we're usually changing the rate. And so first you have to find the rate, and sometimes he tells you straight out, but other times he tells you the distance and the time, and you have to put them together to find the rate. That's the trick of all of these. So let's practice that in an actual problem. And I'm going to write at the top, rate equals distance over time equals a length over a unit of time. Okay? This helps us tap into the problem and figure out which numbers go where, because we can usually find these numbers in the problem. Let's do a homework problem. It's homework 71-4. Hyanna managed the first 40 miles in 8 hours. If she doubled her speed, how long did it take her to manage the next 20 miles? Okay, this is a really typical problem. John wants us to double the rate, doesn't he? She doubled her speed. But we don't know her first rate because John didn't tell us her rate. He told us that she ran 40 miles and it took her 8 hours. But look, this is a measure of length, right? Miles measure how long something is. And so that tells us that this is our distance. Hours is a unit of time. So that tells us that this is the value we should use for t. Do you see how I took this information and by looking at the units carefully, I could find, oh, you're measuring length, you're measuring time. That means you must be the distance and you must be the time. You have to use your understanding of these units and what they're measuring in order to reach this conclusion. But this is super important because now we know how to take these two numbers and find the rate. So the first rate of this woman, Hyanna, I believe is how you say her name, is equal to her distance, 40, and we can put the unit here too, 40 miles over 8 hours. Her distance over her time. Here's where we see it again and again, right? So it is helpful if you just memorize it in this form. Okay? Now, the alarm bell that should be going off in your head is that we always want to get the denominator to, well, let me put it this way. We want to reduce the fraction. Okay? And in this case, we can see 8 goes into 45 times. So it will be 5 miles every 1 hour. Okay? John almost always makes the numbers turn out really cute. And while we could write this as 5 miles per hour, which is how we would do it if we were writing a story about a boy who was walking to the store and he was going really slow. No, actually 5 miles per hour is a pretty good walking speed. We don't do it like this for math purposes. We prefer to do it like this so that we have that fraction, right? Here we're getting rid of the fraction and just writing the units as a little statement. This doesn't work as well for math. We want to write it like this. Okay, now, when we double the speed, when we see those words, That means it's twice as far in the same time. Okay? That's the way we want to change our fraction. We want to double the distance. But we want the time to stay the same. Distance over same time. This is two ways of saying the same thing. Twice as far, double the distance. That's the same thing, okay? So in our example, what we would do is we would find for our second rate, the first rate is 5 miles over 1 hour, so this one is 10 miles over 1 hour. I doubled the distance. She ran twice as far, so 10 miles instead of 5. Same time, 1 hour. Okay, so that's how I go from the first rate to the second rate. Sometimes they might say triple the speed. Okay, so then we would multiply it by 3. Or sometimes John might say she increased her speed by 2 miles per hour. Okay, so in that case we add, all right? We go from 5 to 7. So we have to listen to how that speed changed. And remember that the word speed is the same as rate. Okay? Those two words mean more or less the same thing. There are some subtle differences when you get into physics, but for our purposes, speed and rate mean the same thing. So when it says double her speed, that means double her rate. Double her rate means that you double the distance, but you leave time the same. There's been some confusion. People think you double both of them. No, if you double both, it's the same rate. You have to change just one. Okay, so then we have her second rate is here, and now we're ready to answer the question. It says how long did it take her to manage the next 20 miles? Okay, so if this is her new rate, we know that rate times time equals distance, right? That's tried and true, we know that. So her new rate is 10 miles for every 1 hour. And we don't know how long it's going to take her. That's what we're trying to find out. So we just leave that as the variable. And then we write in the new distance is 20 miles. Okay, and we know 20 miles is a distance because we figured out, excuse me, I want to show you. We figured out last time that distance is a unit of length. So when it says how far does it take her to run, or how long does it take her to run the next 20 miles? Miles is a distance, so we know we plug that in for the distance. We know we need to use her second rate because John's telling us she's running at her new rate. If she doubles her speed, how long, blah, blah, blah. And that's how we know where the variable goes. It says how long will it take her? So the time is what we're trying to solve for. All right? Now all we have to do is solve this. So you can see, you guys, there's a lot of steps involved in these problems. They're by far the most complicated kind of problem we've had yet. But we set it up. Here's her new rate. We don't know the time, but we know the distance she needs to cover is 20 miles. So now we need to simplify this. And what I'm going to do is I'm going to multiply it by 1 hour over 10 miles. I'm going to use the reciprocal because I want to keep those units in the problem. This is 20 miles. I'm going to put that unit in. And so I'm going to multiply this by 1 hour over 10 miles. Writing in the units can be quite confusing, but we're going to need to do that a lot in the future. So I'm helping you get used to it now, okay? And it's fun because they cancel. All right, so we multiplied this. This is her new doubled speed. We figured it out right here. We used it here. We used the reciprocal to make it go away so we can solve for t. We multiplied the other side by it. This is all gone now. Now look what happens here. These units cancel, and our answer is going to be in hours. That's what we want because we want time, right? And now the numbers all cancel, and we get 20 over 10, except for that, right? We're multiplying this, remember, as a fraction. You can do that if it helps you. So now we have the ones we can ignore, 20 over 10. That tells us the answer is 2 hours is how long it's going to take her to run those last 20 miles, which makes perfect sense because she's running 10 miles an hour now. So 2 hours, right? You could do that in your head, but again, Joel, I want to make sure you understand the process because the numbers will not always be so ridiculously obvious. And what I want to do is just double check this answer. I've got my answer book right here. Yeah, that's correct. All right. So I hope this helps you understand, first of all, how to identify the rate and the time and the distance in the words that you're given, how to arrange them so that you can calculate the rate if that's not given to you. And then we also talked in more detail about how you change the rate. Double the speed is John's favorite, I believe, so that you double the distance, but you use the same time, right? Because she's going faster. Triple the rate would mean triple the distance. There's different ways he can play with that, but this gives you kind of some guidance on how to do that. And then here's how we set up the equation and solve it. I was looking to see if I could find another of these problems. Let me just flip quickly. Okay, here's one from lesson 73. Let me do one more. Okay. So this is 73, problem 4. Okay, and I'm going to write again. Rate times time equals distance. And then if we divide both sides by t, we find out that rate equals the distance over the time. Now, here's this one. The rate of production of the machine was increased to 1,400 bottles every hour. Bottles? Bottles? What do bottles have to do with rates, times, or differences? In this case, and this is tricky, the distance part of this equation can also refer to what we often call a job. The job in this problem is bottling cans of hot sauce. I don't know. It's a Tapatio factory. So this is similar to what we would call our distance, or again, we can call it the job, if that makes a little more sense. But the bottom one is definitely time, right? So we can see this is a rate. Job is the one that makes more sense for this, okay? So this time, instead of having a distance, a unit of length, it's an amount of production. So job equals the amount produced. Okay. How many bottles could the machine produce if it operated for 8 hours? Okay, well, we created the rate, right? The distance over the time, or the job over the time. So this is our rate. And how much time do we have? Oh, we have 8 hours. So T equals 8. So we're going to use this formula with this rate that we calculated. So if our rate is 1,400 bottles for every 1 hour, I'm abbreviating because life is short, and we multiply it by 8 hours, we want to know how many bottles will that produce. Okay, so this answer we want to be in bottles. Let's see. So that will be our job, right? The job equals the amount produced. All right, and you can see all the numbers are on one side. This is fairly simple. All we have to do is take 1,400, multiply it by 8. So it looks like we're gonna get a lot of bottles of Tapatio. And let me just double check the answer and make sure that that's right. 73 for 11,200, yes. And let's just put, oh, I did. Okay, so this is the answer. So rates can be used for things other than distances. And when we're using a different kind of setting, we often refer to that as a job, right? The job is to bottle things. But we use the information in the same way to create the rate, and then we use the rate in this equation to answer either the time or the job question, right? It would be in this problem. Okay, so that's what I think makes everybody's heads go crazy, is that we're using two forms of the same equation in different ways depending on what John's giving us and what we need, okay? They are confusing. Keep asking me questions about them because every problem is different. And I can't give you one set of steps that will always work. You have to use these equations and some good algebra skills, and you have to logic it out. So we'll keep working on these and you will master them. Okay, goodbye.